A very good day to everyone watching this video. I am Dr. Deepak MS, Assistant Professor of Civil Engineering, BMS Institute of Technology and Management, Bengaluru, Karnataka. I am the team leader for this study tour of ATAL Tunnel under AICTE Youth Undertaking Visit for Acquiring Knowledge YUVAK scheme. I would like to introduce our team from BMSIT for AICTE YUVAK ATAL Tunnel Study Tour Visit. Myself, Dr. Deepak MS, Assistant Professor of Civil Engineering, and my colleague, Mrs. Shobha R, Assistant Professor of Civil Engineering. Sneha VP, Final Year BE Civil Engineering. Madan Kumar J, Third Year BE Civil Engineering. Adarsh L, Third Year BE Civil Engineering. Adikeshwar Reddy CN, Third Year BE Civil Engineering. Sheikh Arshia Sadaf, Third Year BE Civil Engineering. Varsha G, Third Year BE Civil Engineering. Alap Mundayo, Final Year BE Mechanical Engineering. Darshan S, Final Year BE Mechanical Engineering. Jitin Kumar B, Final Year BE Mechanical Engineering. And Tarun Pachuri, Final Year BE Mechanical Engineering.
In 2002, BMS Institute of Technology and Management was started. BMS Institute of Technology and Management has been established in a very lush green serene campus of 21 acres, single plot, very close to the airport of Bengaluru, Kempegoda International Airport. Now it has 8 undergraduate programs, 3 postgraduate programs and 10 PhD programs. The institute has received grants from Department of Science and Technology and the Naval Research Board, Vision Group on Science and Technology, Government of Karnataka. There are so many government agencies they have received grants from. We also have what is called as Innovation Cell, Incubation Center, as well as the Entrepreneurship Development Cell. Innovation Cell is largely driven by students, for the development of varieties of their ideas into proof of concepts. And once the proof of concept is ready, we have what is called as Incubation Center.
In this video, we like to share our knowledge acquired and experiences in our study tour to all our friends. We are fortunate and pleased to be the final batch to visit the inner core salient features of ATAL Tunnel along with BRO officials and the technical team. During our visit, we gathered a quantum of knowledge and experiences involved in construction of such megastructural project for our India. We feel proud to be chosen and granted by AICTE for this study tour under YUVAK scheme. We came to know about the construction methodology, processes and obstacles faced during the successful completion of the project during the briefing session. ATAL Tunnel, also known as Rohtang Tunnel, is a highway tunnel built under Rohtang Pass in the eastern Pir Panjal range of Himalayas on Leh-Manali Highway in Himachal Pradesh, India. At a length of 9.02 kilometers, it is the longest highway single tube tunnel for all weather conditions. The tunnel is at an elevation of 3,100 meters, that is 10,171 feet, whereas the Rohtang Pass is at an elevation of 3,978 meters, that is 13,051 feet. It was inaugurated by Prime Minister Narendra Modi on 3rd October 2020. The cost of the entire project is Rs 3,200 crores, named after former Prime Minister of India Atal Bihari Vajpayee. The tunnel was built using the new Austrian tunneling method, NATM, and drill blast technique. The length of the tunnel is 9.02 kilometers with horseshoe-shaped cross-section of finished width 10 meters. Designated vehicular speed maintained is 80 kilometers per hour. Uniformly dipping alternate sequence of quartzites, quartzitic cysts and quartzite dolite schists were in thin bands in this geological strata. The maximum overburden is 1900 meters with average more than 600 meters, say 1970 feet. Fiber reinforced concrete ranging between 100 and 300 mm thick is the lining provided to support the strata. It has been equipped with semi-transverse ventilation system with 3 large fans separately circulate air throughout the tunnel. A 2.25 meter tall and 3.6 meter wide emergency tunnel has been integrated into the tunnel cross section beneath the main carriageway for evacuation during emergencies. Fires inside the tunnel will be controlled within an area of 200 meters and fire hydrants are provided at specific locations throughout the tunnel. The tunnel also has a public announcement system to make important announcement in the emergency situations, for which loudspeakers are installed at regular intervals. SCADA software has been installed to monitor the traffic inside the tunnel. The construction and maintenance of the tunnel is done by Border Road Organization.
So this is the model of this project, and the top section is a ventilation duct. Okay, this is a ventilation duct, and this is the emergency egress tunnel. Okay, the lowest part. Whenever there is an emergency and you have to come out of this tunnel, you have to take this path. Okay, so to access this tunnel, at every 500 meters there are access doors on your right. So the place where we are standing, it is called South Portal Ventilation Building. Okay, this tunnel has got 2 portals. Portal means the opening of the tunnel. So we are at the South Portal. Another portal is called North Portal. So all of you know that, huh? Good. So if you go from south towards north, at every 500 meter on your right side, so you will see the exit door, and that door will lead you to this tunnel. As I said, this tunnel is being used as a ventilation duct. Mechanical engineers के लिए ventilation important है. Ventilation duct, how it works? Because since you are going inside the mountain, it is a very long tunnel. It is around 9.02 kilometers. No? If you walk inside 500 meters, 600 meters, you have to depend on artificially, fresh air injected inside because there is no air flow. So when traffic moves inside such tunnels, in the highway tunnels, in this cavity you will find there is a bad air, due to the smoke, some dust particles, So that smoke has to be taken out of this tunnel, isn't it? Otherwise, people moving inside, they will feel suffocated. For that, we are continuously taking this bad air out of this tunnel with the help of fans. We call them axial fans. Those axial fans are at this portal building. So since this, look at this picture. This is the main traffic movement area. Just above this, we have installed the fans. 3 fans are there. 1, 2, 3 fans, and they are just above this traffic movement area. So somewhere here we are having our fans. Okay. So those fans, what are they doing? Those fans are continuously exhausting the air out of the tunnel. Those fans are located at this level. At this level, those fans are there. So how will they take the bad air out of this tunnel? So this ventilation slab is also goes along with the tunnel. All the way 9.02 kilometers is this ventilation slab is, okay. and at every 50 meters there are openings in this slab. And when we go in the tunnel inside, you will see on the roof that there are some cutouts, openings are there. One on your left side, one is on your right side. Adjacent to each other at the interval of 50 meters. Since these fans are taking air out, so those openings are facilitated with the motorized fire dampers. Okay, wherever we know that there is a bad air inside, so we open those entries, those open cutout, those fire dampers. We open in that particular area where the bad air is. Okay, and our fans are continuously operational, so they will take bad air of that particular area, this section, and from this section that air is going out. So whenever there is a natural suction of the air, some pressure also comes inside. So we are taking bad air out of this tunnel with the help of this upper section, and the pressure is going inside to the base of the tunnel. Okay, so this is how our ventilation system is working. And other features are here. We are having telephones at every 150 meters. Yeah? So whenever you feel any problem inside, so you will see the telephone near to you and you can use that and ask help to our telephone. There is fire hydrant system. Mechanical engineers know about fire hydrant system. Those fire hydrants are there to fight with the fire. Normally, fire hydrant system is equipped with the water tank, a pumping system, and the fire hose and nozzles from where we take the water and guide the water at the fire. So we have a fire water storage tank, a very big tank inside the tunnel. There we store the fire water, and there we have the pumping system. We have all electrical arrangement for the supply of that pumping systems. Then we have the continuous fire hydrant system. At every 75 meters we are having the fire hydrant cabinets. There we are provided the hoses, the nozzle and the couplings. Whenever there is a fire incident, our trained operators goes to near to that location and they use those fire hydrants. Okay. I have already told you about the emergency exits. There are turning cabins inside this tunnel. Turning cabins means if some vehicle has got down, so it has to be taken out from the nearest portal. So with the help of those turning cabins are again a big room kind of areas where the vehicle goes back and turns and come out. So we are having turning cabins in this project. The air quality monitoring at every 1.1 kilometers. If you cannot monitor the air quality in this tunnel, how will you know that which area has to be opened? So air quality monitoring is also there. Based on the air quality monitoring, visibility checks, we open, the automatic system opens that particular area. Those fire dampers gets open and the bad air get out of this tunnel. Then we are having the FM rebroadcasting system. So in the complete tunnel we are having the variable message signboards. Those message signboards can be programmed as per the requirement. Okay, on those message boards we will display the message that switch on your FM. Because when you are inside the car you cannot listen those announcements which is being paged on the speaker system. So as soon as you switch to the FM system, you will get the recorded message of our operator can give you the message what to do. Okay. We have the CCTV surveillance, which is very important. Okay, because we need those kind of helping hands, and we have that strong helping hand with the help of CCTV. And every 60 meters we have installed cameras. Those are very good cameras, high definition cameras, and we have installed the high zoom length cameras also, PTZ cameras. We can zoom in, zoom out up to 1.5 kilometers inside the tunnel. So no one can escape by doing wrong things. And those cameras are, few of them are programmed with artificially intelligence-based incident detection system. If somebody is taking, going in the wrong direction, overtaking, over speeding, so that will be detected. If somebody has stopped taking pictures, so it will be caught and punished. So that is why stoppage in the tunnel is not allowed. These are the main features of this tunnel. We have a separate ventilation system for this emergency exit tunnel, because this tunnel has to be always facilitated with the fresh air. Because in case of emergency, this area has to have fresh air inside. Because somebody is taking this emergency bath, there is no fresh air, he will die inside. Because it is very easy, very happy to see tunnel bright and shining. But when you are actually inside the mountain, so you have to depend on the systems created by the electromechanical equipment. Okay, we are just at the entrance of the tunnel. We'll go inside, and you will feel more fascinated and more excited to see this tunnel inside. But everything is being managed by our team. They are doing very hard work. Okay, so these things are there. Then again, we are having a drainage system. Whenever there is a unwanted seepage inside, that water is channelized to this main drainage system. We are having one perennial drain here. That drain collects the water here, and from there it is again diverted to this main tunnel. So there we are having the power supply system, because everything runs on the electricity. So we are having the electricity supply system. We are using the same tunnel to lay our cables. So this section of the tunnel we are having our 11 kV and low voltage supply cables. This section we are having 11 kV and 33 kV cables. This tunnel is also giving power supply to the people of the other area, because that area was inaccessible before this tunnel, and the power supply connection was very much not reliable source of the supply, because the supply was connected with the Manali and all. So in the heavy snowfall, those lines were not in the services. So for 3 months, 4 months, 5 months, they were without the power supply. Now that region is also having power through the tunnel. These are the main features. Previously, it was taking around 6 hours to reach to the other part of this tunnel through Rohtang Pass. After commissioning of this tunnel, 6 hours journey is reduced. Okay, that journey can be covered in 1 hour. So this is the main benefit to people who are staying in that area. They can access the medical facility in the nearest town. They can access the complete India all the seasons, because this tunnel is connected with the all-weather road connectivity. So these are the main features, and we'll go inside the tunnel. We'll take the little bit, and we'll show you this building first. Okay, so let's go there. And if you have any question, you can ask. You feel free to ask any question. Okay,
सिविल also बता दें कितना साल हुआ कैसा
it took around 10 years to construct this tunnel, and there was a major fault in the tunnel. So at around 2 kilometers inside, so the tunnel was civil engineers was facing some challenges to construct, go through that portion because of the strata and bad rock quality. So it took around 3 years time to pass through that area. That in that particular section, the tunnel's cross section is like this, circular section. So, and these are the photographs during the construction into that section. There is a shot about that location from where the water was coming inside the tunnel, and it took a lot of time to dive that cleavage points. Serena. So there are many. Since I am an electrical engineer, but I can share my experience. I have seen many things at the sites. Whenever they face the loose strata or bad quality of rocks, classified glass, Class 5 and class 4 is the bad quality rock, highly valued rocks. So they have the different support systems. Sometimes they go with the steel ribs. Okay, steel rib support system with
shotcrete.
Sorry?
Shotcrete and
Yes.
steel ribs.
Steel ribs, then lattice structures with the shotcretings. Shotcrete, you understand shotcrete? So the cement slurry is pressurized. Cement slurry is injected towards the support reinforcements. And sometimes they go for the rock bolting. Okay. With the help of the rock class and rock anchors, rock bolting is done. And they drill at the particular locations with the interval of 1 meter, 1.5 meter based on the strength of the rock. Those kind of support system is there.
If they stabilization of that rock, then they
Thrust block stabilization.
Or mechanical question.
that chamber that we are talking about, ventilation, are they governed by the air quality monitoring or
Yes, air quality monitoring, and we can go for manual or right on the system. So manually we operate कर सकते हैं. We can operate it manually and normally they are open to
they know that they are now quality, air quality is there. So they will operate from there and it will operate from there. There's a lot of reliability on that.
Yes, we have the double redundancy in the OMC network. We have
Everything
double redundancy in the optical fiber network system. We have one network here, one is here, three is here. We are continuously monitoring the temperature of with the help of the real time temperature. We are monitoring the external weather of the tunnel. So everything is being controlled. Illumination is there. At the entrance you can see the heavy lights. Those lights are for the people who are coming out of the tunnel. Because outside there is a huge level of the light and your eyes has to be protected. Otherwise, if your eyes are not comfortable with the outside area, you will get hit somebody. You know? So those daytime lights are also there.
right? Both entry points, there are more lights.
Okay. So can you please call your vehicle here and we will go inside the tunnel.
Yes.
From the command center.
Oh.
So this panel belongs to the HVAC system, the heating, ventilation, and air conditioning. Those ACs are also there. They are the double cycle ACs. Okay, in the winters they give the warm air. In the summers they give the cold air. And this red cylinders you see, these are the FM200 gauge cylinders. These are connected with the hydrant, again gas hydrant system.
Yes.
So this is a gas hydrant. So this gas is used to fight with the fire caused by the electrical things, electrical short circuits. For the electrical fire we use FM200 gas system. And we were talking about the UPS system, no? To provide the uninterrupted power supply for this tunnel, we are having the UPS backup. That is inside that room. You can open that door. So we go inside. System, these are the maintenance-free batteries. We don't have to put the electrolyte. We don't have to top up the electrolyte in these batteries. And these batteries are very good batteries. This is a very much reliable UPS system. These are feeding the complete light system, that automatic PLC panel systems, CCTV surveillance. So normally we do not bring anyone inside here. So you guys are lucky. For these rooms we have these ventilation systems. It is again inside the tunnel. We are almost 3 kilometers inside the mountains. Without these systems we cannot stand here. No? We will feel suffocated.
So while working, how they use
We provide the ventilation with the help of the jet fans, and we have flexible ducts, circular flexible duct.
One is the supply and other one is exhaust. This was diffuser, na? That was for exhaust and this one for supply, fresh air. This one. That was for exhaust. You will take air outside.
While the construction.
And whenever you see there is a height difference in the exhaust and supply ducts. If you put the exhaust system down, it will take all the pressure. Okay.
So I have to inform. Just inform before you came here. That we are came here for a visit. Don't inform the policeman or someone else that some intruder is coming in this.
So this is the kind of phone everywhere you will find in this one. This is the model is
You can call.
Press this button.
Test कर रहे भाई. They are very effective.
Very quick. Now we are going to
This camera also. You are under camera surveillance. So don't do everything. You can go. There is 18 pieces.
some of you can still this one, some of you can
Below that road now we are.
So this is our emergency egress tunnel, which we were talking about in the presentation. So this tunnel is exactly below the main. Okay, the center line is the same. The traffic is moving just above this floor, this slab. Traffic movement is there. And we are below this tunnel. And whenever you access this tunnel, how do you know that how far is the nearest exit? You have come almost inside the tunnel at 6 kilometers. Okay? So
This side 3.19 kilometers, this side 5.84 kilometers.
every 25
So this
meters you
long
will be having these wayfinders in the main tunnel. So they will guide you to the nearest exit door. And as soon as you come inside this tunnel, there again you will find one wayfinder. It will tell you how far is your nearest exit.
South border, north
So here from 3 kilometer you have to go and you will get exit. This side 5.84 kilometer you have.
And from the mechanical point of view, wherever you go in the world, whenever there are the fire hydrant system, they are always painted with the red color. So whenever you see any red color pipeline, it is for the fire hydrants or fire protection system. Maybe the gas based or nitrogen
Pressurized
based
water
or
is there
water based.
for injecting the fire.
7 concentration.
This tunnel has got all the electromechanical equipment rated for 250 degrees centigrade temperature and 2 hours fire rated. So for 2 hours these equipment will run in case of there is a fire incident. This emergency tunnel is equipped with the UPS backup system with 2 hours backup.
So
In case
light,
of
light
power
you will get
failure,
light. If there is no
you
light,
will not
it will
feel
run.
any darkness.
Light you will get 2 hours.
Since we are underground 3 kilometer inside the mountain, without artificial light you cannot see anything. Without fan system, without fresh air, you will not feel comfortable. All of you are feeling comfortable here? Yes. So it is
Yes, you are
because the
getting fresh air
electromechanical
here.
system is working. We are having this monitoring system, air quality monitoring system. This tunnel also.
CO, NO, and methane is detector, separate detector.
You can check the reading also. This one is CO, that one is methane,
In
and the
this
third one is for the oxygen. You can watch there 21% oxygen is there. And last one is NO.
The proceed to air. So again that point, you find that light is coming from higher temperature.
The good part is that if we detect any oxygen reduction, the ventilation system is automatically run. Like there is a fan in the fourth quarter, it will compress the air in this system.
That thing happens when somebody is he becomes stressful with their fire incidents. If somebody is having some problem with the fire and smokes. So that in that case, somebody should be he will not be alone that time. No, he should be very helpful.
Let
to
me
each other.
tell you one thing.
You
If
can
any
ask the
incidents
help.
happen, there is a camera. That is 1.5 kilometer zoom capability. So if anything is happening in this tunnel, so the control guy sitting in the control belly, he will watch throughout all the tunnel. It's 9 kilometers.
Where is person is
There is
there.
a monitor.
So immediately additional help will come to save.
They can watch.
And you can talk to the control room and their
Keep feeling, because suddenly you will not become faint. You will feel some, so immediately you have to go and
आगे मॉनिटरिंग करे लगातार हम कैमरों से, तो अगर बोलते हैं 5-10 मिनट में आपको हम देख लेते हैं एक बार. The operator sitting in the control room is continuously monitoring this tunnel also.
any abnormal activity happens in this tunnel also, it is monitored. And in the worst case, we have 2 electrical operated vehicles for this tunnel.
One is here.
One is standing here for the demonstration.
One is
you do this immediately.
Another one is at the
Take
bottom
time.
side. So those big help will come in that vehicles. So there is small section is, this is the small section, small vehicle. And in this tunnel, that vehicle with the smoke, the diesel fuel or fuel based vehicles are not allowed.
So battery operated.
Because they will again pollute the air of this area. So I think if you have any question, you can ask.
तो बड़ा सब दिखता है भाई.
So now you are feeling that good, it is good tunnel?
Yes, sir.
This exit tunnel will open at the same port, near to the same building where we were having lecture in the model room. Near to that model room,
This exit,
this tunnel.
Take you left side. So only one out. There and this side.
No, you don't have to go up. When you have accessed this route, you have to go with this tunnel.
With this tunnel.
Yeah, but then you have to.
From you will get that
You
road.
will climb up.
Climb up and up to you will get that main
Ramp
road.
will be there. Yes.
Through ramp you will go up.
Here you can take some photos for your project.
We, the faculty, students and management of BMS Institute of Technology and Management, Bengaluru are greatly privileged for providing the opportunity in visiting ATAL Tunnel under AICTE YUVAK scheme. The construction of ATAL Tunnel is surely an engineering marvel, unique of its kind and a pride to our nation. We wish to cherish forever all the memories and experiences gathered during the trip. The study trip has inspired young minds to think in higher order to build in larger scale career projects. Our special thanks to the BRO officials, Lieutenant Colonel Sunny and Mr. Pramod for their great support. Our wholehearted thanks to Mr. Arvind and Mr. Saravanan for their brief explanation about the construction and maintenance of ATAL Tunnel during the study tour. We further look forward for such like good engineering study tours to actively participate and get educated that will be helpful for us throughout our Indian life. I take immense pleasure in thanking AICTE for providing students such high level of exposure in studies. I express my wholehearted gratitude to our institutions, management, principal, dean research, head of the departments, faculty and students of civil engineering and mechanical engineering. And I also thank all other those who have helped us in organizing and ensuring that we had a safe and comfortable trip. We will either find a way or make one. Jai Hind.